During this film, you will have to take down readings from the screen. We're going to investigate the mechanism of this reaction. It's the reaction between bromine and an alkene, the gas propene. The reaction takes place in a solvent, methanol. Here's the bromine. We take some out by pipette and filler. And run it into the methanol. Now the propene is bubbled through the solution of bromine in methanol. The solution is decolorized as the bromine reacts with the alkene. We must now work up the reaction mixture to get out the product. There's water in this separating funnel. The reaction mixture is poured in. Then we add diethyl ether, ethoxyethane, which will dissolve out organic substances. The ether forms a layer on top of the water. The funnel is vigorously shaken to mix the two layers. Then we run off the bottom aqueous layer, leaving the ethereal solution in the funnel. This should contain the reaction product. We use dried magnesium sulfate to remove any last traces of water. After a short time, we filter the mixture. Any product from the bromine-propene reaction will now be here, dissolved in the ether. We shall use this gas-liquid chromatography machine to investigate the product. In the machine, there's a sort of oven which contains the chromatographic column. The sample comes in here as vapor at the temperature of the oven. The column is coiled into a spiral to save space. It's filled with these inert granules. They've been coated with an inert liquid. Vapors have different solubilities in this liquid. A carrier gas coming in mixes with the sample and carries it round the coil. The carrier gas is nitrogen from this cylinder. If we put the coil back in the oven, we can now look at its other end, where the individual components emerge after being separated in the coil. They come out at this detector, which is fed with hydrogen from this cylinder and air from this one. The hydrogen is burnt at the detector. You can't see the flame, but if we hold a cold glass surface over it, there's the condensation from the burning hydrogen. Now, when a vapor has travelled right through the spiral and reaches this flame, it will change the flame's electrical properties. We inject the sample here. It's vaporized inside the oven and passes through the column. This is the syringe we use to inject the sample. It's graduated in microliters. The drop is 5 microlitres, pretty small, but we'll be using even less in the actual experimental runs. So, that's where we put in the liquid we're investigating. The boxes contain circuits to detect electrical changes in the flame. The results are fed across to a paper trace recorder. At the moment, the pen is stationary, just tracing out a straight line as the paper comes slowly out, indicating the passage of time. Now, our sample from the propene bromination is a solution in diethyl ether. So first of all, let's run the pure ether through the machine to find out what happens. We inject 0.5 microlitres of ether, a tiny quantity. Inside the oven, that ether will be almost immediately vaporized and it will pass into the chromatographic column. As we injected the sample, we made a kick on the paper trace to show the time at which the experiment was started. You can see it there on the paper. Now, as time passes, the ether vapor is being swept through the spiral column by a stream of nitrogen, and it will take a certain time, depending on its solubility in the liquid inside the column, to reach the hydrogen air flame at the detector. When the ether vapor reaches the flame, we should see some indication on the paper trace. Watch. There, a big deflection, showing that the ether has got to the detector at the end of the column. Now we can stop the recorder and remove the paper trace. You must be ready to take down a reading from the trace. We lay a transparent graticule on top of the trace and line it up so that we can measure the time it took for the ether vapor to pass through the column. We call this the retention time for the diethyl ether. The time is measured along the vertical axis. Here it is. 2 squares. Call it 2 units. It doesn't matter what the units are. 2 units. Ether retention time, 2 units. Write it down. Now we can run our experimental liquid through the machine, the product of the bromine-propene reaction in ether. We use the syringe again. And we inject a tiny sample into the apparatus. Once again, as we do this, we make a starting kick on the paper trace recorder. Now, both diethyl ether vapor and the vapor of the product of the propene bromination will start their journey along the chromatographic column. There's the kick on the trace. Nitrogen is carrying the vapor along towards the flame. And there's a deflection. Something has reached the flame at the top of the machine. It looks like the ether peak again, which is what we should expect since our test liquid was a solution in ether. After about 3 minutes, another peak. Some other vapor has reached the detector. This must be the product of the reaction between bromine and propene. Afterwards, you can work out what you think this substance is. Now get ready to take down some more readings. The first retention time, 2 units. This first peak must be ether again. Now for the second peak. It took longer for this vapor to reach the detector. Write down the retention time for this second peak. It's about what? Well, there's 5 units. 5, 6, 7. It's about 7.8. Estimate it, write it down. Let's now go back to the solution of bromine in methanol we started with. We're going to add a new substance, a salt lithium chloride. Once again, we pass propene through the solution. Once again, the bromine is used up. We work up this liquid as we did before, adding water, extracting with ether, then drying the ethereal solution. And we inject a tiny sample of the solution into the chromatographic column as before. Vapours will again be produced, which will take different times to pass through the spiral column and reach the flame. There's a first peak. Once again, this is probably the ether. About 1 minute later this time, a second peak. A second vapour has reached the flame. Then, about 1.5 minutes later than that, yet a third peak. 3 substances present in the sample have passed right through the column and reached the detector. Now for a lot of readings. First, the retention time, first peak. 2 units. So that's the ether again, as we thought. Get ready to estimate the retention time for the second peak. Here it is, 5-point-something units. Estimate it, note it down. That's the retention time for the second peak, obviously something different from last time. Now for the third peak. Write down this retention time. 1, 2, 3, 4, 5, 6, 7-point-something units. We had this one last time. We can now estimate the relative quantities of the 2 substances represented by the peaks if we measure the areas they enclose. For this we'll need first their heights. So write down this, the height of the second peak. And this, the height of the third peak. And we'll need the width of the peaks at about half their height. So here's the reading for the second peak again. The breadth halfway up, about 0.8 units. Estimate it, write it down. And write down the corresponding width halfway up the third peak. About what? 0.5, 0.6 units? You estimate it, write it down. Now you can use these mechanisms. Lithium chloride is very important. Your booklet notes tell you what to do.